waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. On we'll go, finding life along the way, melodies we haven't played. No, I don't want no rest, echoing around these walls, fighting to create a song. I don't wanna miss a beat. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays.
All right, hey everyone. Hopefully everyone had a good Tuesday. It's kind of getting towards the holiday season, especially this week with Thanksgiving coming. So if you're still working, hopefully things are slowly winding down. Over the next day or so, and you get to enjoy your holiday. So tonight we'll be diving into creating the API for our Flask application, and so what I'll do is, go over some of the main components that we need to implement into the application, and then we'll actually create some API endpoints, and then we'll test it. We'll test it using an application called Postman. Julio, happy holidays. Hey, thanks for joining the stream tonight. Hopefully you're you and your family, friends, you have a good Thanksgiving. So with that being said, we'll jump into it tonight. Hopefully we'll get the API up and operational. I plan that it'll probably be read only, so we'll only be able to we'll create some Git endpoints basically. So we won't be adding anything to the database or updating any items. We'll just try to get it up and functional, and then hopefully we'll be able to kind of extend on that in a future stream. So, but I thought it would be good if we could start with creating kind of a flow chart, if you will, more or less a diagram, I guess you could call it. But I know we talked a lot last stream about interacting with the database using Python code, and specifically Flask. So I wanted to quickly, hold on, actually. I wanted to make sure I get my music started. Well, hold on. Let's see. There we go. Don't need it that loud. I didn't have music last time, and it felt just too quiet, so I had to make sure I remember. So and then hopefully in the bottom left of the stream you can see there's a little like music app or dashboard that shows you kind of what song is on. So it's all DMCA free music, using the copyright, what's the name of it? No copyright sounds. They actually have a really good YouTube channel, and that's where the intro and outro song comes from. So let me just, okay, it is on the right playlist. All right. Anyways, sorry for that. So I figure, I'm a visual learner, And I figure, let's just start by kind of talking through what an ORM is. And if you don't know that acronym, obviously I'll go over that. And then how the user is going to interact with this application. So that way, whenever we're coding it, it makes a little more sense. Because I know I tossed around a lot of acronyms last stream, so we'll kind of go through that. So let's start with, and I kind of have these three kind of starting points, I guess you could call it. We have the user/app. So this could be any sort of consumer of the API. And consumer might be the better word, but user application consuming the API. Then we have the Flask app, which obviously hosts the web UI, all the logic. It's the back end. I didn't really create a layer here for the web UI or the API itself. Actually, I think I might add that here in a second. But anyways, we have the Flask app, the backend, which is obviously Python. And then we have the database. In our case, it's SQLite. And so I wanted just to quickly go over kind of how all of this is connected. So between the database and the Flask app, we're using a library. And we talked about it last stream, but it's called SQL Alchemy, and that's the ORM. And so obviously I'm not using the exact shapes. I probably should with some of these with this flowchart, but the idea is for us to connect the dots. So here's our ORM, and what I'm going to do is basically put the role that the application, the Python library, whatever is being used, as like the top row, and then the second row will be what it actually is. So in this case, an ORM is, and I will just add the dictionary, maybe. Add to dictionary, whatever. So we have the Flask app obviously has Python, the ORM. So ORM stands for Object Relational Mapper. It's a big mouthful for basically what it is it maps your Python objects to kind of the SQL database. So instead of using Python to submit SQL statements, I'm actually going to turn that down just a little more. Instead of doing like select star from table name, what we're able to do is interact with, from a Pythonic standpoint. We're not putting out SQL code, and that obviously it's cumbersome. It's very error prone if we use just straight SQL syntax, and there could be potential security loopholes with that, right? And that leaves you open to SQL injection and everything like that. So the ORM is kind of the way to go. Hey Ganesh, I'm glad you can join tonight. So yeah, Ganesh, basically all we're doing so far is just we're doing a visual diagram, so that way we're able to visualize what we're doing tonight, and basically we're building the API portion of the Flask app. So what we'll do here, and just so let's see, will this? Oh man, that's gonna bother me. Not straight. Okay. All right. So what we're doing here is I'm just connecting the dots real quick to draw the arrows, and then we'll kind of talk through it. So SQL Alchemy is kind of that glue, and I talked about it last stream. There's two Ganeshes. Okay, so we have two Ganeshes, and honestly, both your last names, if they are your last names in your YouTube name, both start with V, so I can't even like say Ganesh V. Who would have thought, man? Well, both Ganesh 1, Ganesh 2, I am glad you're here. That's What a coincidence, right? Okay, so where was I? Man, the two Ganeshas threw me off. No, so SQL Alchemy, and we played with that a little bit last stream, and just to kind of bring it up for you, basically what that, we created a model which models our database using a Python class, right? And so that's kind of where I was saying we're taking, instead of creating a table using like SQL syntax, we're using Python to do that. And here are our columns here, the column names, and then the specific properties or attributes of the column. So whether it takes their string values or integers, what's our primary key, whether the value has to be unique, and so on. So this is SQL Alchemy, right? This is kind of the basis of creating those database models. Besides creating the models, SQL Alchemy also allows us to do very simple commands to add data to the database. So you'll see here db session add, db session commit. So add stages our changes, and commit actually saves them to the database. So SQL Alchemy allows all of that to happen, right? Without us touching or committing any sort of direct SQL syntax to our database. Granted, we are using SQLite 3, and thanks to Clay Curtis in the last stream for recommending a VS Code extension to where we can actually open this database right up in SQLite, or I'm sorry, in VS Code. And so you'll see what our database looks like, right? So what SQL Alchemy allows us to create tables, add or remove records, create columns, using the models. And so that's kind of the glue between our Flask app and our database. So what we're adding tonight is one other little piece. And technically we could have used this piece last stream with just, instead of SQL Alchemy, and it actually integrates with it, but it's called Marshmallow. And I know it's a very funny name here, but this is the Flask integration, but you'll kind of get the point, right? It's a object serialization and deserialization library. And you're probably like, oh man, we just went over what an ORM was. What's serialization, deserialization? And this you'll actually learn about if you're beginning network automation, and you're interested in like the Cisco DevNet certifications. You actually learn about the serialization and deserialization concepts. And I actually pulled up a pretty good Stack Overflow article or response that had these Wikipedia definitions that I thought were pretty cool. So the one that you'll find a lot, especially when you're starting out, is serialization, is converting data types between Python and JSON. So JSON, is you may or may not know, that's kind of the main data format or encoding for APIs. So if you were to use Postman and go out and hit an API endpoint, there's a good chance that you're going to get JSON data back. Obviously, there's different data encoding, such as like XML, but JSON's kind of the popular one. And especially if you're familiar with like or heard of REST APIs, JSON's kind of the de facto for the encoding for those APIs. So yeah, we're not actually going to be looking at this definition as much as this one here, the top one, because this one has to deal with data storage. And obviously, we're dealing with that with a database. So serialization is the process of translating structures or an object into a format that can be stored. So think of from a Python object to the database, right? Whereas deserialization has to deal with extracting that data from the database and back to, in this case, like a Python object. So what exactly is, what does that mean for Marshmallow? So Marshmallow, as you can see here, it actually, like I said, can double up as a ORM, I believe. I haven't actually tested it. I've always integrated it with SQL Alchemy. But you'll see here, we create models. And in this case, these are considered, I know we talked about in the last stream, data models, table models. These are still your table models, because you can see here, we have columns. And actually, this example is basically assuming you have an ORM, which in our case, like I said, is SQL Alchemy. So I won't kind of draw comparisons anymore. We have SQL Alchemy as our ORM, and we have Marshmallow as our serializer and deserializer. Gosh, man, that is a mouthful. So what does that mean, right? We have SQL Alchemy that obviously says, all right, this is what the table's going to look like. This is how it allows us to get data from the table and then also add data to it. So what's Marshmallow do? It allows us to create what's called a schema on what the output data is going to look like. So it takes data from the database and formats it to a specific schema. And this allows us to, I guess you could call it validating our data before it basically is returned. Otherwise, what you could do, technically, is say, okay, well, return data, and for all the return data, let's get this specific record, right? Instead of doing that, what Marshmallow does is it's a little thin layer that says, okay, we're getting data from the database. This is how we expect the data to look, and then this is how it's actually going to be sent to the user. Okay, so it's pretty interesting, and I honestly, before tonight, haven't really used it. Like I said, the only time I've really messed with ORMs and serializers is with Fast API and SQL Model. And SQL Model makes this extremely easy because it is integrated or is built on, Fast API is built on Pydantic, and that is a data validation library, Python library. And so it's very easy the way they have it integrated. Whereas this one's a little more like, okay, we use SQL Alchemy for the ORM, the database transactions, and then you use Marshmallow to actually, with the schema validation, and then sending the data to the user. So, this is just kind of showing you, right? You create the models. We've already done this part, and then we have to define a schema, and then we can output the data to a view. And this is where we add a route to our existing application. And then, this is an example of what the user may get. This is the optional integration, which we'll actually be doing tonight, where we can integrate what we've done with SQL Alchemy and integrate it with Marshmallow. So you'll see here, we declare our models, which we've already done. We've only really created the one model for device. And then we have to create the schemas. So here are the schemas. And then you'll dump your ORM objects. So dumping it basically returns it to the user. It dumps it to a specific encoding. So in our case, we want to dump it into a kind of a JSON format. Or loading it. Loading it basically says, okay, we're taking in JSON data. So for example, you wanted to do a post or a put, or a user did a post or a put to your API endpoint. Well, Marshmallow could take that data in, and with via its schema, it could validate the data and then allow you to load it into an ORM object, which then obviously gets translated to your database. So hence all of what I just talked about is why I'm creating this flowchart. So that way we have a better idea of kind of what we're doing. So tonight, like I mentioned, we're doing this serializer. I'm not gonna, well, I guess we could just put it in the say serializer. I'm not going to add deserializer, but just know that, well, I don't want people to get confused. Marshmallow. Right, so let's make that just a little wider here. All right, so this is kind of the missing piece for our API. And the way this works is, this is going to be confusing, I think. Actually, no, it's not. Okay. Hopefully it's not confusing. And honest, there might be a better way to do this. Let's do that. And let's do a text box real quick. Text, and we'll say commit or get data from database. So that's what this does, and then maps Python objects to data to database. Okay. Basically what I'm trying to do is add a little bit of context to this, so that way if someone wants to, because ideally what I'm going to do is just put this as a JPEG file in the Git repository, so that way people can kind of have an idea. And actually thinking about this. I want it to make sense. That's the biggest thing with making these diagrams. I want it to make sense. Julio says, I'm that dude that downloads icons to place all over the place where titles work just fine. Yeah, I mean, icons would work, man. It's just add REST call codes in the flow. Okay, yeah, no, that actually may work. The problem is I don't want to, I'm not mapping this specific application. Well, I guess, that probably would be best. Yeah. Let's see, post to some front end that translates to X. Yeah, okay, yeah, that's a good idea. But in our case, we're actually just doing we'll just do a get call. But good call. Funny enough, good call there. So we'll do a get call. The problem is, maybe helps you and the user know what's all going on. Yeah. How about let's do this? You're right. Let's work on. I'm trying to. I guess my problem and where I'm going with this is, the serializer deserializer is really right here with the ORM, right? Because the ORM is what interacts with the database, and then the serializer I mean, I guess it would be in line. I guess that's the best way to kind of put this. So what would actually happen is Not to be more confusing, but just throw it in right there, dude. And instead of that, we'll just say that. Boom. You know what? I think that might do it. That might do it right there. Because if we make it, if we get a little too crazy, I think if we went any like deeper than that, it like more words might just confuse people. So I won't even put get call. I'll just keep it very open-ended. Take what I type with heavy barrels of salt. I don't know what I'm doing. Julio, of course, you definitely know what you're doing. Are you kidding me? That CI/CD series that you did was phenomenal. You definitely know what you're doing. Don't even. All right, let's see what we got here. Oh no, we're not doing this, right? There we go. Oh no, it's because this is no bueno. There we go. Oh no, you're telling me. Hold on. I gotta remake the shape. The arrows aren't gonna line up, and then it's all gonna go downhill. Alrighty, delete that. There we go. That's funny. I was planning on making this diagram, and I was like, I think it'll help me, it'll help the viewers, it'll kind of help everyone. Did not expect it, to have all these little technical difficulties. All right, you know what? That's it. All right. So yes, everything has to pass through Marshmallow, whether you're trying to commit data to the database or you're pulling data out. That's kind of where I was going. I was trying to add it to the side because it was new, and I could say, hey, like, this is, what we're adding. Of course, that didn't work. Let's just kind of bring this all up a little bit. All right. So that's kind of it. We'll only be focusing on the deserializing tonight because, like I said, we're just doing GET requests. So, the GET request would come in, hit the Flask app. Technically, there's really nothing to serialize because remember, with GET requests, there's no data. A put or a post would have that data. So you would serialize that data, apply it to the database, and then deserializing would, remember from that Stack Overflow article, we're taking data out, we're translating it back into a Python object, and then we're also transforming it into output, right? And the output in this case is going to be JSON back to the user. So that's it in a nutshell. I apologize for any confusion with creating this diagram, but I will include the diagram in the Git repository. And so that way, if you guys want to look at it, there's obviously a bunch of alternatives, and I might put a little asterisk in here somewhere. There's a bunch of alternatives to data serializers, ORMs. SQL Alchemy, I will say, is definitely one of the more popular ones, but you can use different, serializer, deserializers, ORMs, whatever. Database, we've talked about that, Postgres, in the past. So, okay, now that we're done with the design overview, let's start jumping into actually some code. So, I already went over that. We'll close that out. So what do we have left, right? We created the database models. That's already there. And actually, as I brought up earlier, we still have our database. So I don't have to go through, recreate the database. Because we have in our model, we have or specified that the host name must be unique. We can't even like go through a trial run of getting the software version again. If you wanted to run this in a production environment, or you wanted to actually like run this as an app, what you could do is create a route to update the database. If the host name is the same as what's in the database and the created timestamp is newer, you could then update the version, assuming that it's different, right? So that was one way to kind of mature this application a little bit. But remember, kind of the whole idea of all of this is to just gather concepts about creating kind of a web front end, creating an API, understanding how a Python web app can communicate with the database, and all the in between, right? So, all right. So what do we have to do here? Flask SQL Alchemy must be initialized before Flask Marshmallow. I did install all of the dependencies. So there was dependencies for Flask SQL Alchemy and Marshmallow SQL Alchemy. So if we open up, actually I don't even need the web app open right now. I'm just gonna do a pip list just to show you kind of what we got going on. SQL Alchemy's there, but I believe up in Flask, I passed it. Yeah, here you go. Flask Marshmallow, Flask SQL Alchemy. So both of those packages are installed. I just wanted to put that out there. And let me actually because we will need it. I just said we didn't, but we will need it to test the API when we get to that point. All right, so we still have to create the routes as well, but I wanted to, obviously we'll kind of do it in order. So we have to initialize the Marshmallow app. So we have to say from Flask Marshmallow, at the top here, we'll just pop that right underneath it here, import Marshmallow. It might take a second for Pylance to figure that out, but it's definitely there. And we'll use the example variable name that they used. So we'll say Marshmallow app. Save that. All right. No, we don't need Postman yet. Sorry. All right, so we already have, the Flask app initialized. We already have the SQL Alchemy database URI configured. It says order matters. You have to make sure SQL Alchemy is before Marshmallow. Done. And now we declare our models. That's already done. As you guys remember from the last stream, we just created one database model for device. Pretty simple. ID, hostname, version, date created. Now you must generate schemas, and you can use SQL Alchemy schema or SQL Auto schema. Interesting. Auto schema automatically generates Marshmallow fields from a SQL Alchemy model. Uses the scope session from Flask SQL Alchemy by default. So what that does is it takes in from our device. It would take in from our device model. It would take in ID, hostname, version, and date created. So it automatically generates the fields for Marshmallow from our SQL Alchemy model. That's probably what we need, actually. and they show you both examples here, right? So, and just for, yeah, here we go. The normal SQL Alchemy schema without the word auto in it associates a schema with a model via the model class meta option, which should be a DB model from Flask SQL Alchemy. All right. So basically, we could do it the long way and more verbose, or all we would do is take in and do an auto schema based on the database model. The only thing, so I wanted to be more verbose with this and just create the model itself, because I want you guys to be able to be able to read it and say, oh, okay, well, I understand how this lines up with this. If I do the auto schema, it kind of just is bleh, like you're not going to really learn too much from it. You're going to say, oh, okay, I just took a model, whatever book is. So let's start writing some code for this. So I already have the database model. And remember, I'm just doing this all in the same, in app.py. You really could and probably should break these out into like serializer.py and then models.py. And so that way, like if this grew to beyond device, so let's say you have multiple tables, you'd want just one models.py file that would have just your models in it, your database models. But in our case, we're just throwing everything in the same file. Right, so yeah, we basically just take that marshmallow object we initialized, SQL Alchemy schema. All right, so we'll do ma dot, and then we'll say, all right, and then we needed the was it class meta? No, it wasn't class meta, right? Oops. I'm just gonna keep this open in the background and just switch between them. Yeah, class meta. Yeah, so class meta, and then we say, okay, what model do we want to model in our schema? We're doing device, right? So this basically ties this device schema to this device model. And you're probably like, okay, well, can like model equals device? Like, how did you know to do this? One, obviously the example, but two, if you read the documentation for SQL Alchemy schema, this base class that we're, that's inherited from, we're able to realize that we can say, okay, well, we just have to declare the model for device, and that basically ties these two together. Now, because we're not using the auto schema that would just automatically pull these values, we want to be verbose with it. That's why we're using SQL Alchemy schema. Right, and okay, so class, and then basically we just go through and do the we'll do ID equals ma dot, is it autofield? Okay, the more I'm reading into this, the more I'm like wondering why we're doing it, but it's fine. We'll just copy this section. So, like I said, it's very verbose and definitely unnecessary, really. But the way I look at it is someone that's reading this off of from GitHub that maybe didn't watch, not in the stream or didn't watch the VOD of the stream, they can easily read this. They can say, okay, the model equals device, which is right here, and then we have the individual fields, the individual columns that are, defined in the device model, and then we're basically creating a field, a field in our schema for each of those columns. I thought I had black install. Maybe not. Okay. Anyways. All right. So now to use the schema, right? So going back to our model here. Actually, you know what? I actually have a better idea with this. So my thing, because I know whenever I first was like looking at this, I was like, okay, I don't know what any of this means, right? So we'll say schemas. So I'm just putting some key terms. We'll just call tables. So hopefully this helps. Please, feel free to let me know in the chat, or if you're watching this on demand, just let me know via Twitter if this kind of helps you. We have the actions on the left, or the purpose, and then some of the key words you may hear with each of the different layers. So schemas, and actually I'm going to extend this a little bit and say serializers. Hopefully I spelled that right. Schemas and /serializers. So that way, whenever like we can talk in circles about this, you kind of have an idea of like, okay, he's talking about schemas. That's going to be marshmallow. So all right, let me just pull up. All right, so we have the schema. It's called device schema. What's next? You can now use your schema. Okay, so we already created the database. They basically created we just created variables. They just created variables for each of the schemas. And so that's what we'll do next. We'll create just a global variable. Actually, no, I don't think we even need to do that, because they're only doing that as an example, but all we need to do is, well, I guess we will. And we won't do a constant. We'll just say device schema equals device schema. Easy enough. Right? That's all they did here. All they did was assign a variable, basically created an instance of this class. And so all they're doing now is basically taking this and saying, okay, we'll dump this record here, because this is an instance of the device table model. So it's just saying, okay, use the schema, dump it to JSON, and dump this specific record, right? So what we're gonna do is go down and actually, I take that back. We don't need it here. So this is where things are gonna flip a little bit. So we have the schema, we have the database model. Now we have to create the API endpoints, right? Because this is all, we can apply this to these other routes as well. Granted, we only have like one or two. But the whole point of it is we want to use it for our API. So over here under Flask app, net auto, there's an API folder and there's a v0.py. So I'm actually using something called Flask Blueprints. And basically what a blueprint is it's a group of routes, a group of, I guess routes, that would be kind of the best way to describe it in plain terms. So you can do a lot of things with a blueprint. Oh, here you go. Represents a blueprint, a collection of routes and other app-related functions that can be registered on a real application later. Defines application functions without requiring an application object ahead of time. So basically, this is like if you wanted to cut your application into different chunks. So right, for us, it's a web UI and an API. Now, a lot of people would say, okay, well, if you create the API, your web UI, if you have a front end like a React, JavaScript, any sort of front end framework, you can just use your API to gather that information and render it to your front end, which is 100% valid. But in our case, we have routes, and we have separate routes just for the web front end, and we're not using any sort of front end framework. But in our case, we created a separate blueprint just for the API, and we named it API underscore v0. And then all I did was to customize it was create a URL prefix. So any route down here is going to be prefixed with /API/v0, right? So if you take this API v0 and you see there's just a route to just /, it would actually be /API/v0 and then another slash. And you'll see here I just created some BS kind of JSON response. And if we pull it up, let me make sure it's working. Okay, so our Flask app's working, right? This is what we did last time with the web app. So now if we go /API/v0/, there you go. So like I said, it's just some JSON with API ping pong version 0. You'll see here, API version 0 ping pong. Okay, so instead of having this, what we're going to do is create a route to say, get device data based on, we're going to get all the devices in the database and all the data back in a JSON response. And then on the flip side, we're also going to be able to, you put in a host name and we could pull just that data for that specific device from the database. So those are kind of sample routes we'll be creating. All right, so we'll keep that base route just for fun. But what we're going to do is say devices. So now we're going to have a route just to, okay. Let's see. Oh, it's because I also didn't get all devices. So you have to change the function name too. And what you see down here, I'm just installing Black, which is formatter. And so it'll do things. You may see everything kind of change as it saves, because it'll do some auto formatting. For example, like the line length, if I go past, like, I believe by default it's like 79 characters, it will kind of reformat things to be on multiple lines, and you'll probably see it as I save things. We want to change to DevNet Expert, Flask. Oh, no, this opened up another terminal. Here we go. All right, so that worked. Okay, so now if we go to /devices, what we'll do maybe and say devices, and we'll just do a simple one. We'll say devices, all device data here, right? And I don't have to do underscores. I'll just, all device data goes here. We'll save that. Cool. Julio says needs to drop. Great job. It's really coming along. Happy holidays, everyone. Hey, Julio, thanks for dropping by. Really appreciate it. And I'm sure we'll talk on Twitter soon. So, but yeah, you have a good holiday as well. Okay, so we were checking the devices endpoint. There you go. So we just got some JSON data back. I know it's probably very, very small on screen, but just believe me when I say in blue it says devices, and then in pink it says all device data goes here. right? So that's just to prove, all right, we got the route working using this prefix and using this blueprint. So the route works. Now we just have to get the data. So to get the data, we need to go to from net auto app import. We need to import device schema. Device schema. Now I think this should work. Yeah, no, okay, so no object name. Let's see if this works. Okay, yeah, we can't import it. Let me see. Need to import. Can I import API from partially initialized module API v0, most likely due to circular import? Let me think about this. So our v0s are here. Well, oh, this is actually technically being called from when it's being when basically it's ran, app.py takes in this blueprint. So really, I just don't know if this is gonna work though. That's the problem. Let's see. This isn't gonna work. Yeah, fudge. Device schema is not. It's kind of crazy too. No, so we should be able to import it. That's the crazy thing. From Flask. No. Flask app doesn't have its own init, right? No. Yeah, from net auto. I had the same problem. No module named net auto. That's not it either. This is where I had it working with this tool with netcheck. Let's see. This is why it's nice to have something that's working. Endpoints. From backend. Okay, so where did I go from here? So was it just from app? Import device schema? But this is where I got the circular import. Yeah, most likely due to circular import. From API v0 import v0. Yeah, from app import device schema. Yeah, this is kind of where it sucks. Let's see. So I see what it's saying. Basically, it's saying you're importing the API blueprint, right? Which are these routes here. And so when you try to import the device schema from the app, if this is getting imported back into app, and then we're trying to import something from app, it's like one big loop. From API v0 import v0. Hopefully that should work though. An idea. Just because I know this app, at least, you know, in my head, it isn't gonna grow too crazy. What we'll do is drop it below here. So what we're doing now, what I'm doing is I'm just taking this blueprint and import blueprint. Okay. So basically, instead of having this folder here, I just moved all of this functionality, the API functionality to, there we go. I just moved all the functionality from that file to the app. Because I initially, whenever I build out an application, I obviously, like, you want to keep it modularized. Okay, and I don't need this. So yeah, you would like I've said before, like you would keep your model for the device in probably a separate folder or folder file for models, and then schema would be separate, and then the blueprints you could keep in a separate folder completely. But I'm just gonna keep it all in the same. So now we're able to get the devices, and we'll pick back up with actually doing the device schema as we talked about. Let me see here. Device schema. Device schema. Well, I don't really need that up here. Alright. Okay, back to what we were doing. Where was I? Here we go. The JSON, or I'm sorry, the SQL Alchemy schema uses the scope created by SQL Alchemy. SQL Alchemy schema subclasses Flask Marshmallow schema, so it includes the JSONify method. So all we're doing basically is dumping the data that we're finding with author, and this. Now, the dump method, I'm wondering. See real quick. Dump method. Okay, so like this is a good example, right? We'll use this example where basically all it's doing is it has the user schema here, and we're just saying use the user's schema, dump all the data from the database that's collected from all users variable, and the all users variable just collects all the data. All right. So we will. So at the very top, what we'll do is say device schema equals device schema. And then we'll say devices. We'll basically follow the same. Oops. Any equals true. we'll basically follow the same format as what they used in the example, because basically all they're saying is, user schema would be for one record, right? The user's schema basically uses this many equals true, so it's saying you're accepting multiple records, so the output's going to be many users in this case, but in our case we want multiple devices. So now what we want to do is say all users, and in our case we're going to do all devices, so we'll do all devices equal device dot all, and all we're gonna do is say what's our returns gonna be, let's see, so we're just gonna return user schema dot dump and then the record. And so in our case we're just going to say devices schema dot dump all devices. And if this works, I'll kind of explain what's going on here in a second. Alrighty. Slash devices. Oh. Interesting. Okay. So let me think about this. API v0. So here's the blueprint. Here's the URL prefix. Let's just move it. This is gonna sound crazy, but let's just move this up a little bit, like right underneath, before the database is even initialized. So that way, interesting. So now it's not even being found. Interesting, because we have the blueprint, or oh, maybe we'll just do this because we're not using that module anymore. Oh, it is missing a required. Yeah. Interesting. All right, let's see. Flask Blueprint. Registering Flask Blueprint. Let's see. I already have the blueprint. That's not too worried about that. Create a blueprint object, use the route decorators. To use any blueprint, you have to import it and then register it. I'm just breaking this thing apart, aren't I? they are to be executed later when you register them on an application. Yeah. So we're using URL prefix, which is used by the secondary name is the Blueprints import name, which Flask uses to locate the Blueprints resources. Don't need it though. Like, yeah, like it breaks everything apart. So, because the whole point of using a blueprint is you would have it in a separate folder. I'm like just tempted. I'm just gonna blow it away. And what we'll do is just do this. We'll keep that. We'll do this. We'll do that. And then we'll just do app route. Yeah. It's sad. I didn't use a blueprint. Because I want to get... Okay, so that works, and now let's see if this works. Okay, so device object has no attribute all. Okay, that makes sense, because I did not, let's see, get all the records from, because I have to do db. Add, delete, get bind, no. Whoa. Let's see. It's crazy too. I had this other little project up too that I thought could help as well. Okay, so device.query.all. Damn. So let's do this. Device.query.all. Let's see if this works. The view function did not return a valid response. The return type must be a string dict response instance, but it was a list. Interesting. Because that should return JSON. The view function did not return a valid. It returned, but it was a list. Interesting. Oh, so he used JSONify. I mean, I guess I could use that, but I'm pretty sure. Dump was oh, there we go. There we go. So I thought that the dump method, where did I read that somewhere? Dump. you can use your schema to dump and load your R. Oh, duh. Yeah. So it didn't actually like. Here we go. JSON, yeah, I mean, so this is what I normally was like used to. Check the decorator. Oh, I'm sorry, Clay. I just saw your message. Check the decorator on your routes. Yeah, so it was weird because I had the name of the blueprint for the routes, but it's fine. It's honestly like we're not kind of. If I was building this further out, which we might get to that point, I'll rebuild that structure. But just for simplistic sake, we'll just have routes, and I'll make just a API routes. Okay. Yeah. So just to kind of highlight what we did there, because I know I probably, whenever I'm kind of thinking through things, I get quiet and just start typing away or copy and pasting. So we blew away the blueprint, and what the blueprint did, which I showed you guys the definition, was it's a collection of endpoints, right? So an API is like a really good example for a blueprint, especially if you were doing different versions, you could create multiple blueprints. So I blew that away, or I'm sorry, I moved it to this app.py file, and then I was having more issues with the, Clay pointed out the decorator potentially. I honestly glanced at it. I didn't see an issue with it, but there could be a chance that I needed to change the name of it. So I just kept you ever kind of solve a problem by just cutting down on the complexity? And it's not much complexity, but I basically deleted the blueprint, and then just, now it's more verbose of the API endpoints are just /API v0, /API v0 devices, which is fine for this small of an application, but where we'll run into issues is if we made this app more mature and created more API endpoints, and then if we try to create like a V1 of this API, it would be tough, because with an API, it's not just like overnight, okay, we're on V1 now. You have V1 in the previous version, which in this case would be V0, up at the same time, and then have some endpoints deprecated over time, or completely remove V0 after having multiple deprecation messages to the developers. So like it's not like okay, we're updated to V1, V0 is gone. There's definitely times where you may see that. It's not really, it's not nice of the developers to do that, especially if you have a lot of processes that rely on the API. But anyways, this kind of dials it in a little more by being a little more verbose. But you'll see, I recreated those API, the endpoints, and the root one just still does the basic ping pong, and then V0 devices, what it does is it queries the device table, gets all the records, and then converts it to a JSON format or encoding. And so you'll see here, that's what we get. And it's tough. I know it's very tough to read on stream, so I'm going to actually pull up Postman and do the same call. All right. So let's pull up Postman real quick. And just pretty simple. We don't have any authentication. We don't really need to set any headers. Now, all of this is possible. You can definitely configure headers, data formats you expect, if we were to add data or update data, but in this case, since we're just doing a GET request, we'll just take the same endpoint, do GET, and hopefully this is a little easier to view. So you'll see, maybe I can zoom in a little bit. No. Okay. Well, sorry. I guess I could just put it in a text file, but you kind of get where I'm going with this. You can easily, let me see if this works. No. View. Zoom in. Oh, okay. Let me just crank in the zoom a little bit. There we go. Okay, so you'll see it's a list. So you'll notice by the square brackets, we have a list, and then within that list, we have our data. That's directly from the database. So you'll see it's in a alphabetic order. So, date created is actually the last column in our database, but because JSONify, what it does is it actually reorganizes the objects to alphabetic order. You'll see date created, hostname, ID, version. So really, now that we have all this data, we can actually specify another endpoint, and we can say, all right, out of devices, we want the host name. So we would say maybe R100. And when we do that, we'll get just this specific record, hopefully, right? So that's the next endpoint we're going to be creating. But just so you guys can kind of see, this is all JSON data, and kind of where the magic happens is you can take all this data. If you have another application, you can do this same GET request. Well, this GET request, and you could take this data and do whatever you want with it, right? So in this case, you could say, okay, well, take the data, the JSON data, and I want only the versions that equal 1733, right? So obviously you wouldn't have your Nexus devices in here, and you wouldn't have these router, R1 or stream switch. You would just have R100, R200. So pretty neat. And this is honestly, the whole idea of these streams is to kind of think about the DevNet Expert. I know a lot of this may be starter material, kind of, I don't want to say elementary, but it kind of is just gets enough into the weeds where you just understand the concept. I am doing things off stream just to, full transparency. But as far as what the stream is concerned, I want this to be interactive for you guys as well. So I don't want to be just head down, coding away and trying to, try to create some complex application, right? That something that I may do on, that's going to be done on the DevNet Expert exam. These streams are really just meant for us to go over these concepts, go over the tools that potentially will be on the test and how to use them. So we, like I said, the Flask SQL Alchemy, the Flask Marshmallow libraries were not included in the requirements text file, but it's good to know how to interact with databases, from a Pythonic perspective, right? So that's kind of why we're doing this. But I just wanted to put out the disclaimer just in case, for the people that have been here for a while, that's what these streams are for, is just to keep you guys involved, and hopefully you guys are learning along the way. And at the same time, I'm learning. Like I said, some of them are very entry level, projects like this one, right? It's not going to scale too far. You can definitely mature it and make it scale, but the idea is if I can explain it to you all, I'm doing something right. That's kind of like, if you can teach it or explain it to someone, that kind of helps solidify it in your mind. So I really appreciate, I always say this, I appreciate everyone that joins the streams and kind of follows along and asks questions as we go. So just wanted to put that out there. All right, so we have all of our devices. And so real quick, let's create one more endpoint. Notice we're about an hour 20 in. Let's create one more endpoint to see how easy. If it's pretty easy, we may create another. But we'll wrap it up with these, with these last couple endpoints, and then what I may do, with the holiday, and then I'll actually be on PTO next week, so I won't be streaming, and so the next stream won't be for 2 weeks. So it won't be, obviously not Thursday, and then all next week I'll be out, so it'll be 2 Tuesdays from now. So I want to be able to close this piece out and then have something for everyone to, kind of review while I'm out. So I'll put all this up on, like I said, the DevNet Expert GitHub, and you guys can pull it down, mess with it. Hopefully, actually, breaking down the barriers of the blueprint and whatnot helped you all like kind of understand, okay, what the blueprint was there for. Obviously, it's for scalability and making this a more modular application, but with the difficulties we've gone through, it's just easier to put it all just in app.py. Hey Eric, yeah, I've been going on for 79 minutes already. Wow. yeah. I try to start around 8 p.m. Eastern. I try not to go too far beyond about like 9:30. A lot of times I end between about 9:30 10 p.m. Eastern. Unless there's questions or we're really on a roll. But yeah, so we're gonna create a couple more endpoints and then kind of close it out. So we already mentioned we want to do an endpoint for one device. And really, and remember, the way we can pull in a variable is, hold on. And I might have to double check that, but basically we pull in a host name that's entered by the user, so that's why like there's these, it's kind of like a variable per se. And then we have to put in as an argument into the function, right? So that way it can be used within the actual function. So, So we're gonna say one device equals device dot query dot filter by. I'm doing this. I'm just telling you this right now. I did all of that by memory, and trust me, I do some preparation for this streams, but I definitely don't read through all the documentation. So all I'm going to tell you right now, oh, I forgot, duh. I have to put it into a schema, or a device schema. .jsonify. Okay. So for my next act, what I'm gonna do is did not, as you probably saw, I did not look at any of this documentation. I didn't look at SQL Alchemy or anything like that. I haven't got any sort of like errors saying, hey, this isn't really a method, or any sort of linting errors. So let's just see what works, right? So I'll first do it through the browser. So we're gonna say /devices/ a host name. So we're gonna say R100, okay? So we'll do R100. Okay, there we go. Yeah, filter by takes one positional host name. Oh. That's what it is. Only problem is I don't know. So the issue was the filter by, and we'll see if there's another issue, but filter by, you have to put in the column and then the value. So this is kind of confusing. And actually, just to avoid confusion, it's a little more, like I say, I'm making this a little more verbose than it may have to be, but I do want to avoid confusion when possible. So the user's putting in a device host name, and then we're filtering by in the hostname column, we're going to try to find the device hostname. So let's try this again. There it is. That's it. That's it. Man, I didn't even look at any documentation. The only thing I messed up was the filter by. I forgot the it's a keyword parameter, right? Or keyword argument. So I had to put the name of the column and then what it was, what the value was, whereas I just put in the value. So there you go. That's the magic show for the night. I didn't look at any documentation to create that route. So, and because it only took like 2 seconds, we'll create one other endpoint. And actually, before we create the endpoint, let me actually walk through what I just did. So device is the name of the table. Obviously, we use .query, the query method, which obviously will think of it. I always try to like read through some of these methods as like translate it to what it would in SQL. So in this case, you would query is like select, right? In SQL, SQL, whatever you want to call it, you would do select blank from and then the table name, right? So we would say, all right, query, so select. Filter by is like the where keyword. And if you don't know SQL or SQL, whatever, then you know some of this you're like, okay, I don't know what select means, I don't know what where means, right? So basically, the where keyword just is a filter, and if you ever write up a SQL statement, so we select where host name, the column host name equals the device host name, which is a variable. And then I tacked on dot first, and dot first basically just says, all right, pull the first record. I believe there might be another method that validates that there's only one record as well. So like pull the first record, and it should be the only record that's pulled or selected. But I'm not going to worry about that. So yeah, there should only be one record because remember in our device model, we said that the host name is where's it at? That the host name unique equals true. So it has to be true, or it has to be unique. So dot first, it should be the only record anyways. And just to kind of prove my point, what I'll do is I'll just take dot first out. And you see there's only one record here. I really apologize. There we go. All right, so I took dot first out. Let's see what comes up. Oh, you know what? Dot first was, if you don't have dot first, then you have to say dot all, or there's like one other method. But basically what we did there was we filtered, but we didn't actually get the results. The dot first is what, besides picking the first record, it's what also gets the results. That's what it is. There you go though. R100. And we'll do one other test. Oops. I meant to keep that up. We'll do R1. That's our iOS V image, so it should be, the version should be like 15.6, whatever. There you go. So we have a working API. Boom. Cool. So what else do we want to do? Select the device by host name. Maybe let's filter on ID. How about that? So if you remember, actually, let me just pull it up. Now that we have a working API, I can do this. So you might remember the ID field is our primary key. So that will always, I know we specified hostname has to be unique, so we can use hostname, but the ID also is unique. You know, it's the primary key. So let's use that. Let's say, all right, well, if we put in an ID, maybe we say devices slash, maybe you do slash ID slash 1, or shoot, slash 1. Nah, I feel like that's too long. We'll just say devices slash 1. And this is probably better if we do a query parameter instead of doing another slash, but just, you know, since we're on the topic of doing creating API endpoints, let's just keep it simple. So we'll say ID, and this offers some flexibility to the user. So we can say get device by ID, and we'll say ID. And I'm just going to add device to the front of this because the column name is also called ID. And we're going to use the same format. So I'm not even going to waste our time. So we'll say device ID. Or no, one device by ID. And we'll query on, so we will still pull from the device table. We'll query filter by the ID, and instead of doing the device underscore host name, we'll feed it the ID, and we'll say obviously the first record that it's pulled. And we'll say, okay, we'll return using the device schema and converting it to JSON. We'll return that device that we pull via its ID. All right, so we say devices, and let's say we want 3. We haven't picked on the Nexus switch, right? So this is device 3, ID 3. Okay, so we'll put in 3. Oh, you know what? I think because because we basically did the same endpoint. We said slash devices slash, and then we basically gave it a variable, device ID or device host name. So like it doesn't know which one to pick. So let's put in a slash ID instead. Boom. There you go. Got the Nexus switch here. Good stuff. Good stuff. All right, so now we can say, and in this case, let's do NXSW1. NXSW1. There you go. So we have a working API that we can get a list of all the devices, or we can get a list of we can get one device and use its host name, or we can get the device by its ID in the database. The only other thing I can think of is getting it by its operating system. And I think we can do that because that was pretty quick. It was a copy and paste, so I kind of feel like I cheated right there. But let's do one last one. So we'll say OS. So now we're gonna say, all right, there's a route to devices, OS, get device by OS. Device. So we're gonna filter by, oops, we're rushing. Device OS. And we're not gonna do first, we'll do all. And we'll do that. And we're gonna say that. Oh. All right, so I know This is why I like to keep with the simple examples, because like what you just saw, like I've rushed through it because like it's already in my head like what next steps are, and I don't talk through it. So I do want to take it just a quick second. So we create a new endpoint, devices/OS, and then we'll put just the OS version. Actually, thinking about it, we don't store the version, or I'm sorry, the OS. We store the version. So how about this? Instead of saying OS, we'll call it version. OS version. Yeah, we'll do that. And we'll just rename stuff. All right. Let's see. Devices. All right. Sorry, I just. We'll say by version. That's just way too long, so we'll just say by version. All right. Okay. So we have our list of devices. Slash devices slash OS version slash, and then the version number. So like in our case, 17.3.3 is 1, right? And what we'll do is we'll pass that OS version parameter or variable into the function, and we'll query the device table, filter it by the OS version, or what is the name of it? Hold on. Version. Okay. So we'll filter the version column by the OS version that was passed in, and we'll get all the records, right? I don't know if this is a valid method, but we're going to find out. I believe it is, but we'll figure it out. So we'll get all the records that are found, and then we'll return, and just a slight difference, we'll be using the devices schema instead of device schema. And the reason for that is because there's going to be potentially multiple results. And remember, we created two different schemas, one for one device and then another one for multiple devices. And we know that because we set many equals true. Okay. So back to here. So we're going to do devices, OS version. I just don't know if I like that OS version. I might just put version 17.3.3, because 17.3.3 there should be two results. Oh, it does work. Man, I'm getting lucky tonight. I'm getting lucky with my code. So yeah, so this gets all the records found for this specific OS version. So technically, and like I said, this probably would be best as a query parameter instead of an actual endpoint, because there's a lot of errors that could happen with this. I mean, you could put in technically the long version of it, 17.03.03. If I do that, there's nothing, right? Oh, and you don't have, and like we don't have any sort of error message, because basically there's nothing found in the database for this particular version. But like, I mean, let's say 15.6, like, see how I actually have to copy and paste this. That's why I said it's like, it's a cool example, but like it's not realistic, because no one's actually going to plug in the OS version. I mean, you could do a little bit like fuzzy regex to where it's like, okay, anything 15.6 will come up under here. Like you could do something like that, but you can kind of understand. Like I think we've successfully, we definitely built the API endpoints, and successfully done a couple different things. We've gathered all the devices that are in our database, all the objects. We've captured, gathered information on just one device by filtering on the host name and the ID. And then lastly, we got the OS version. So we basically can pull up any device, or all the devices that are running a particular iOS version. So, 17.3.3 in our case, there's multiple devices here. This is, like I said, it's not perfect because, realistically, like you have to get this to a T for it to work in our current implementation. But you can figure out ways, escaping it. You could add different checks and make it a little better. But I just want to pull it up here as well, so that way you guys can see it through Postman. It's a little easier to read, I think, in Postman too. I mean, the white contrast in Firefox is crazy. So yeah, you'll see we pulled up the devices by the host name, and we'll say ID. And like I said, this is really where query parameters would come in, because you would never do like ID/ and then the ID. You would probably do something along the lines of devices query parameter ID equals 3. So what this does is it pulls all the devices and then it filters just based on the ID. And whenever I say query parameter, basically it's everything after the question mark in the URI. So that's like a better way to implement it, but just because, we're in an hour and a half stream, I would just like, getting a nice working example for you all. So we got it by host name, by ID. And then lastly, we'll do OS version 17.3.3. Boom. So cool stuff. So yeah, we got our API working. Like I said, there's some things that definitely could be improved, but ultimately, we got it working. So, yeah, I will get this code. I'm going to comment some of it. I'm going to comment what each of the API routes do. I'll comment the schema, like just put some inline comments to explain, schema. But I'll have this up on GitHub probably within the next 15-20 minutes. It won't take me that long. And then what I'll also do is save this diagram that we kind of talked over towards the beginning of the stream, to kind of get an understanding of like how all these pieces work. And that way you have a reference point. You kind of like, hopefully after this you learn that, okay, with Flask, and you hear about like, okay, putting a web backend or web framework and piecing it together with a persistent data store like a database, and putting a front end, like all those, like you're starting to understand like what's in between all of that, right, to make it happen. You have your ORM with your table model, your database models, your table models, and then you have a serializer, deserializer, that does your schemas and your data validation. So, and like I said, there's plenty of other libraries out there. Like tonight we use SQL Alchemy and Marshmallow, but Pydantic is a really good serializer / data validation tool. SQL Alchemy, offhand, besides SQL Model, which I talked about in previous streams, SQL Alchemy is a very popular ORM, especially with Python and Flask. So yeah, I'll save this and put it into the the README of the Flask app, if there is one. If there's not, then I'll put this JPEG. It'll be like a JPEG or PNG format. Will definitely be in the Flask app repository, so that way you all can see it. But besides that, I don't really have too much else. I guess if anyone have any questions? I know I'm about 30 seconds ahead of everyone, but if you have any questions, put them in the chat. I'll stick around for a little bit, minute or so, just to see if anyone has any. If not, I mean, this has been a really fun experience. I think hopefully you guys learned something. I definitely did. I knew about like how to configure SQL Alchemy, and I've used like SQL model for creating schemas and kind of your data models, but never used Marshmallow and SQL Alchemy together, especially in this format. So it was definitely fun. I had a fun time with everything. Clay asks, "Are you doing any sort of error checking?" No, I don't have any sort of error checking currently. That's something I need to add in. So, yeah, I don't have any sort of error checking for the database. I need it for whenever pulling records from the database for sure. Yeah, let me see. Pretty sure they'll be sending bad data to your apps on the exam. Yeah, that's a valid point. Yeah, I have to add in some error checking with this, and on top of it, create some testing as well. So using PyTest and create some unit tests and integration testing. So that actually is the testing part I was going to definitely do on a future stream, but I'll also add in some error handling as well within that same stream. So we'll definitely, this isn't the end of the app for sure. We'll add in some error checking, and then we'll also add in some unit tests and some other things using PyTest. So, but yeah, that's a good point. They definitely will be probably sending some bad data to the applications for us to catch it. So yeah, no, definitely valid. But yeah, I need to add in. There's a lot of things I would need to add into this app. I mean, I literally just got the skeleton up and running, but like none of these applications have, or I'm sorry, none of the endpoints have any sort of error checking. So yeah, I'll need to add that. But yeah, we'll be doing that in a future stream. Probably the week I get back, we'll be doing some adding some error checking, kind of making this a more matured application, and then adding some unit testing and kind of talking about that with PyTest. So good stream tonight. Thanks, Clay. I appreciate that you stick around. I've seen some of the work you've done, and I know some of this may seem elementary, and it's kind of starter material per se, but I appreciate that you stick around and kind of help me out, especially some of just the weird issues. So thanks for sticking around tonight. Just as a FYI, I'll be out. I mentioned in the beginning of the stream, obviously no stream Thursday with Thanksgiving, the holiday, and then next week I'll be out on PTO, so I will not be around a computer. So the next stream will be 2 weeks from now, 2 Tuesdays, which is December 7th. So I'll be back December 7th. Most likely we'll dive back into this application. If not, we may start looking into some telemetry, getting that started. And so definitely we'll see how the computer resources are can handle the multiple Docker containers for, the TIG stack or elk stack, whatever, we take a look at. So thanks again for everyone that joined and, talked in the chat, and I will see you all in 2 weeks. As always, if you have any questions or just want to communicate with me, I'm on Twitter at DevNetDan. You'll see in the outro, and feel free to hit me up whenever. All right, peace.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on